Hello students, welcome to SSB Crack Exams. I am your mentor and educator. My name is Ramchandra Gade. Today in this lecture we will study the chapter of time, speed and distance. So first let's see the content of the chapter. First we will see the definition and introduction to the chapter, then important formula related with time, speed and distance. Later conversion formulae for conversion from one measurement system to another measurement system. Then later we will see the strategies to solve different problems related to this chapter. Finally we will look into some questions, which type of questions are asked in different defense recruitment exams, and finally we will just have a summary. We will recall what all that we have studied in this chapter. So let's start with the introduction and definition of the chapter. Let's see what is first. We will see distance. Yes, what's distance? It is movement of person from one place to another. Okay, it can be movement of person, it can be movement of vehicle from his source position to destination position. If a person or a vehicle moves from one position to another position, its displacement is defined as distance. Okay, so it is measured in two units, meter and kilometer, for normal problems. Okay, then later we will see what is speed. Speed is defined as distance covered per unit time. Okay, how much distance is covered within particular unit period of time is called as speed. The more the speed, the less is the time. Okay, speed is inversely proportional to time, and the standard units of speed measurement are meter per second or kilometer per hour. Okay students, now we will see the next definition of time. Time is the duration involved to cover the distance. Okay, when a person or a body moves from his source to destination point, whatever the duration is required, it is called as time. Okay, its unit are seconds or hours. So these are the basic definitions of time, speed and distance. We will now look into important formulae. Okay students, this entire chapter is only dependent on one formula. Speed is equal to distance upon time. Okay, we will denote it with this triangular diagram. This is a triangle of SDT. Okay, here S stands for speed, D stands for distance, and T stands for time. Okay, now if D is covered with black circle, means we have to find out distance. So distance has below two variables, S and T. Okay, they are adjacent to each other. Means let's understand that it as product. Okay, so distance is product of speed and time. We will learn in this way, in form of a diagram. Okay, in a diagram of a triangle. Okay, so now when circle is around speed s, then what is the formula? Distance upon time. Here d and t are one below other, so they are in fraction form. Okay, so formula for speed is distance upon time. Now we will find the formula for time. Okay, what is the formula for time? Distance upon speed. So these are the three basic formulae. Speed is equal to distance upon time, distance is equal to speed into time, and finally time is equal to distance upon speed. When we have one innovative formula for average speed. Okay, now in some problems there are given that a person travels x distance with speed a kilometer per hour, and later he travels a distance of y kilometers in speed of p kilometer per hour. Then find the average speed. Okay, now we have to take in consideration the both the speeds, both the time taken and both the distance covered. Okay, to find out the average speed. So what is the formula for average speed? Total distance covered upon total time taken. So what is the total distance? Whatever the distance he has covered with first speed, then whatever distance he has covered with the second speed, then whatever distance he has covered with the third speed, that is d1, d2 and d3, and finally up on time, total time taken, summation of all the time durations is added. Okay, so what is the time duration? T1, T2 and T3. So we have to add it them and write it there below. So these were the important formulae. So we have another formula for if the distance is constant. See, students, if distance is constant, we have the concept speed is inversely proportional to time. So if this distance is constant, so this product will have is also constant, speed and time product. So we will have different formulae like s1 s1 t1 is equal to s2 t2 and s3 3 okay. So till sn tn at the nth instance. So this is the formula if distance is constant, okay. Then speed can vary, means if there is large speed, the time taken is less, and if there is less speed, the time taken will be more, okay. So this will be remain constant, however the product will remain constant. So now we will look into the another concept of relative speed. Relative speed is defined as means speed of if two bodies are moving, then whatever the second body, the speed of second body with respect to first body, or speed of first body with respect to second body is defined as relative speed. We will look its precise definition. A relative movement is a movement of the one body with relative to another moving body. Suppose if two trains are moving, so one train is moving in forward direction and the other train is coming from the opposite side. So we will see the movement of the another train. So if we consider the first train, the motion of the another movement train will be relative motion, okay, and its speed will be relative speed. Now see, suppose two opposite, as we considered the example of trains. So suppose the both trains are moving at a different speed s1 and s2. So their relative speed will be s1 plus s2 because they are moving in opposite direction. Suppose they are moving in same direction. So what will be their relative speed? Mod s1 minus s2. Okay. This is to be understood. These are two cases of relative speed. So we will now look into some conversion formulae. In the questions we are given so mostly speed in kilometer per hour or meter per second, but we have some situations where we have to convert kilometer into meter or seconds into hours, or speed kilometer per hour to meter per second. So we have a standard convention to standard formula to convert the speed of kilometer per hour to meter per second. Let's see what is that formula. We will derive that formula. See, we know 1 kilometer per hour is equal to, see, 1 kilometer is converted into 1000 meter. So we write it over here 1000 meter per hour. So 1000 upon 1 hour is converted into seconds. So seconds will be 1 hour will be 3600 seconds. So 1000 upon 3600 second meter per second, what will it give? 5 by 18 meter per second. So we have conversion formula. 1 kilometer per hour is equal to 5 by 18 meter per second. So we wherever we have formula, we have to convert the speed into kilometer per into meter per second to kilometer per hour. Then we use this formula. Okay. Similarly, if we have to do vice versa, means we have to convert the speed to kilometer per hour to meter per second, then what we have to apply the conversion factor, we have to multiply it with 18 by 5 because it's just reciprocal of 5 by 18. When this goes on this side, it becomes 18 by 5. So we write it over here 18 by 5. Okay. Similarly, we will see distance and time conversion. So for time conversion, we have 1 minute is equal to 60 seconds. Also 1 hour is equal to 60 minutes. So 60 minutes is also 60 into 60 seconds, that is 3600 seconds. Okay. We have applied this concept to derive that speed conversion formula. So we must remember the time conversion also. So now we will look into distance conversion. What is 1 kilometer? 1 kilo, the word kilo means 1000, okay, 10 raised to 3. So 1 kilometer is always 1000 meter. So students, these were the conversion formulae. We have to apply it in the problems different that are asked. So now we will look into different strategies, different tactics, different techniques to solve the speed, distance and time problems. Let's see the first tactic. If a man travels with distances d1, d2, d3 and so on, in different time t1, t2, t3, then the average speed is equal to d1 plus d2 plus d3 till dn upon t1 plus t2 plus t3 till tn. Okay, so we know what is the average speed concept. Total distance traveled, total upon total time taken in traveling the distance. Whatever total distance is traveled, irrespective of their speeds, we have to just add them. Okay, upon total time taken. Okay, so whatever the time is taken by different speeds, we have to add them. So whatever is the resultant speed, that will be the average speed. So okay, we find such kind of problems to find the average speed of a person or a vehicle. Okay, so we can use this strategy to solve such kind of problems. So now let's see the next strategy. If a man travels with different distances d1, d2, d3 and so on with different speeds s1, s2 and s3 respectively, then what is the average speed? See, here the same concept is applied, only the time is replaced with the formula distance upon speed. See, the numerator in the above strategy and this strategy is similar, only the difference is between the denominator. Okay, so here denominator t1 is substituted with t1 plus d1 upon s1. Okay, similarly d1 upon s1 plus d2 upon s2 plus d3 upon s3 and so on. This is the average speed formula if distance and speed are known. The above formula was used when distance and time were known. Okay, okay students, we will now see the next strategy to solve the problem. If a man travels with the speed s1, he reaches destination t1 late. Okay, what situation is given? If a man travels with speed s1, he reaches his destination t1 late. Okay, there is a late time duration of t value t1. Okay, now if he travels with speed ts2, so he reaches t2 time before. Okay, now in the next condition, what he does, he travels with speed s2, so now he reaches t2 time before, t2 time in advance. So then what is distance between the two places? Okay, we have to find the distance between the two places. So distance between two places is given by shortcut formula s1 into s2 plus t1 plus t2 upon s2 minus s1. See children, this kind of this is a special case. These questions are seldom asked. So if you have any question, if you undergo any question of this type, you can just substitute the values of the speeds and times and get the answer. Okay, students, now we'll see the next strategy. If an object increases or decreases its speed from x kilometer per hour to y kilometer per hour to cover a distance in t2 hours in place of t1 hours. Okay, now see here, you take one relation. T1 hours corresponds to speed x kilometer per hour and T2 hours corresponds to speed y kilometer per hour. So the speed is we changed. You remember the word changed means, because change word includes both increasing the speed and decreasing the speed. Okay, so if there is situation where speed was x kilometer per hour and time taken is t1 hour. Okay, it converts to speed y kilometer per hour and time is t2 hours. So what is the distance traveled? See, if there is a generalized formula for such type of problems. Distance is equal to xy. Distance is equal to speed product of the speeds upon difference of x and y. Difference of the speeds. Okay, whole multiplied by change in time. Whatever the change in time is there, t2 minus t1. That will be the product. This is the generalized formula for solving such type of problems. You can get such kind of problems in the NDA or CDS exams. This is just formula based question, you can solve it very easily. Now you see the next type of problems. If in a certain time d1 distance is traveled with speed s1 and d2 distance is traveled with speed s2, then then the ratio d1 by s1 is equal to d2 by s2. See, here we use the relation of inverse proportionality. What we have inverse proportionality? Speed is inversely proportional to time. So, but here time is constant, right? So d upon s ratio is also constant. Distance upon speed ratio will be also constant, right? So if when time is constant, distance upon speed ratio will be constant. So d1 upon s1 is equal to d2 upon s2, right? Now we will see next situation. If distance is constant, see, we know distance is product of speed and time. So if distance is constant, the product of speed time will be constant. So s1 t1 is equal to s2 t2, so on. Okay, students, we will now see the next subtopic of the chapter, boards and streams. So here we apply the concept of relative motion, okay, relative speed. So now we have to consider, we have to find out speed of boat. There are two situations in this type of subtopic, that when the boat moves along with the speed of the stream, means the boat moves in the direction of the stream, okay, and in another situation boat will move opposite to direction of speed. So, okay, so now in both these situations we have two different concept and two different terms. First is speed of boat, okay. The speed of boat is considered sb. So sb is speed of boat which is considered in still water, means when water is silent, whatever is the speed of the boat in silent water is called sb, okay. Then another concept is speed of stream, whatever is the speed of flow of water is called as speed of stream. So now we will consider the first case, speed of boat moving against the flow of water. See, in the relative motion concept we have studied, when two bodies are moving against each other, means here what are the two bodies? First is boat and other is stream. So if they are moving against each other, then we had subtraction of the both the speeds, okay. So we will apply the same concept over here, speed of boat in still water minus speed of stream, okay. The speed of boat must be greater than speed of stream, then only it can it can flow against the stream of water, okay. Now we will see the next case, when the boat is moving along the flow of water, along the stream, okay. Then what is the speed of the boat? It is addition of speed of boat in still water plus addition of speed of stream, okay. This is the two concept. Now we will see another subtopic related to trains. Now, first we will consider that the basic formula for solving boat and stream problems is the basic formula of speed into time is equal to distance. We have already studied this formula. Now we will study the topic of trains. See, trains, there are different cases of trains we have to study. Means if a train first case is if train is passing through a stationary object. If a train is passing through a stationary large object, means if it can be a pole, means a simple object can be a pole, large object can be a truck, means a standing truck. If what is the speed of train to pass through a truck, okay. So for that we have to consider different concepts, means length of train will be considered. If there is large truck, then length of truck will be considered to find the time taken to cross the train, cross the truck, okay. So we will see one by one each case. First we will have to make it sure that speed into time is equal to distance. This is the basic relation for solving all train problems, okay. I told the same point for boats and stream as well. I repeat the same concept, that speed into time is equal to distance. This concept is applicable for each and every train problem. See, now we will see some cases that when train is crossing a moving object, a speed is taken to be relative speed of train with respect to that object. See, suppose a train is crossing a moving object, means if another car is passing besides train, then we will take the speed as relative speed of train with respect to that running car, okay. A relative speed concept we will applicable for that case. Now when the train is passing through a stationary object, then how much distance that will be required to cross that object? length of train 2 plus length of object. If the object is small, like a pole, its length is negligible as respect to length of train, so we will neglect the length of pole, okay, means width of pole. So if the object is a car or a truck, then we have to add it with the length of train for finding the distance to be covered for crossing. Okay, these were the two basic things to be kept in mind while solving questions on trains. Now we will see some cases, means when train passes through a stationary object, through a moving object, then what will be the speed and what will be the length of object and train. We will see it. Suppose train is passing through a stationary object without length. A stationary object without length can be a pole, okay, its width is negligible as compared with length of train. So what will be the application of that speed, time and distance formula? Speed of train into time t is equal to length of train, okay. So the length of train will be distance to be covered for a train for crossing that stationary object, okay. Now next case, train crossing a stationary object with length. See, if the stationary object is a truck or a go down of length LO, so what will be the time taken? What will be the speed, time and distance relation? St into T is equal to LT plus LO. Here this is similar to first case, just we have a variation of addition of object length, okay. In the first case we had the object length 0, so if we put 0 in the second case, we will get the first case, okay. So now we will see the next case, train moving crossing a moving object without length. See, if a train is crossing a running man, what will be the speed time distance relation? St plus S0 into T is equal to LT. Oh, if they are moving in same direction, means a person is trying to catch a train and he is moving in the same direction of train. So what will be the speed time and distance relation? St minus S0 into T is equal to LT. So this was the case 3. So if the now we had seen that case without length, if we see case with length, what we will get? Train crossing a moving object with length. First case is if they are in opposite direction. So formula is St plus S0 into T is equal to LT plus L0, okay. Because we always remember, whenever there is a opposite direction convention, we always have to add the speeds. If they are in same direction, we always have to subtract the speed, okay. See, then we have what we have formula, train crossing a moving object with length. If they are in opposite direction, we have to add the speed st plus s0 into t is equal to lt plus l0. If they are in same direction, then what is the formula? St minus s0 into t is equal to lt plus l0. So these were the different cases to solve the different train problems. Now we will see the some questions based on the concepts we have studied. Okay, let's see the first question. Beam can cover a distance in 1 hour 24 minutes by covering two-thirds of distance at 4 km per hour and rest at 5 km per hour. Find the total distance. See, this is a simple time distance relation we have to apply. First, we will convert this 1 hour 24 minutes uh, into fraction form. See, we whatever we have to find, we will assume it as variable. Consider it as x. So let's distance be x. So 1 hour 24 minutes it can be converted into 1 hour plus 24 by 60, because 60 minutes are in 1 hour. So we will then divide minutes by minutes. So we will get in hours form. So what is 24 upon 60? 2 by 5. So 1 plus 2 by 5 is equal to 7 by 5, right? Now we will apply the relation of time, speed and distance. So we have the time, right? So now what we have total time. Now we can get individual time. Our total time is always the sum of individual time. See, there are two journeys. First two third journey with 4 km per hour, and and latter one third journey with 5 km per hour, right? So what will be the speed? For first case it is 4 km per hour, and for second case it is 5 km per hour, right? See, at the denominator we have speed, so what we will have at the denominator? Distances. Okay, so we know that in the first journey how much distance was covered? Two-third distance. Now we have total distance of x, so two-third of x will be 2x upon 3. Okay, then one-third of x will be 1x upon 3. So we will add them both, and let's see what we get the answer. Yeah, finally we will reduce it into x by 6 plus x by 15 is equal to 7 by 5, which is finally 7x is equal to 42, and answer is x is equal to 6. So option D is correct, right? So if you are used to this concept, you will have to just note down one equation and you can solve it orally. Okay students, now we will look into another question. A train requires 7 seconds to pass a whole pole, while it requires 25 seconds to cross a stationary train which is 378 meters long. Find the speed of train. See, in the first case, let's consider is as a train A. Okay, train A has some length, right? So for crossing that pole, it will have to cross that its own length. Okay, whatever the length is of. Suppose it will if it has length of LA. Okay, train length of train A will be LA. Okay, so it will require distance. It will require 7 seconds to pass through a pole. Means it will require to cover distance of LA, while it requires 25 seconds to cross a stationary train with 378 meters. So let's see. So now here there are two cases. When the train crosses object without length, and next situation the train crosses an object with length. So now we will have to find the speed of train. So let's see. First it is 7 into st into is equal to lt. St is the speed of train. Okay. So now in next case what we will have? Next situation, time is required is 25 second, and speed of train is st, right? Now distance to be covered is lt plus 378, right? So now we have equation in form of two variables. Now we can easily solve it. If we put lt is equal to 7st, what we get? st is equal to 21 meter per second. Okay, but in the options, all the options are given in kilometer into kilometer r form. So we will have to apply the conversion formula for meters per second to kilometer per hour conversion. So what is the factor? 18 by 5. Yes, we have to multiply 21 by 18 by 5. So finally we get the answer 75.6. So option A is correct. Now we will see another question. A and B are two stations 390 km apart. A starts train from A at 10 a.m. and travels towards B at 65 km per hour. Another train starts from B at 11 a.m. and travels at A at 35 km per hour. At what time they meet? See children, in this question there are two different stations, and from two different stations, two train travels in opposite direction. In Means with the verge of meeting each other. Okay, so now both the trains travel. They meet at a certain particular point. Okay, so train, suppose consider as a train A and train B. So train A will consider the distance traveled by train A is x kilometer, and consider distance traveled by train B is y kilometer. So what is the total distance? X plus y is 390 kilometer, right? So now we will have the relation distance moved by first train in x hours is equal to plus distance moved by another train in x minus 1 hour is equal to 390, right? Then we have a general equation of means speed time distance relation. 65 into x is equal to plus 35 into x minus 1 is equal to 390. See, we have added two different distances. 65 into x. What is the x? Time. So 65 is speed. Time into speed is distance. So what we get the value of x? 17 by 4. So answer is 17 by 4. So what is 17 by 4? If we convert it into hours and minutes form, we get 4 hours 15 minutes. That is at 2:15 p.m. Okay, students. Now we will see next question. A railway passenger counts the telegraph poles on the railroad as he passes through them. The telegraph poles are at distance of 15 meters. What will be his count in 4 hours if the speed of the train is 45 kilometer per hour? See, the speed of train is 45 kilometer per hour. So in 4 hours, how much distance will be? How much distance will be covered? 180 kilometers, right? So 180 kilometers has 1,80,000 meters distance, right? So in so telegraph poles are at distance of 15 meters, right? So in 50 meters there is one telegraph pole. So for 180 kilometer or 1,80,000 kilometer, how many poles will be there? 1,80,000 divided by 50. That is equal to 3,600, right? So option C is correct. Okay, students, this was the easiest problem of the lecture today. So students, these were questions related to time, speed, and distance. Now we will recall whatever we have learned in this chapter. Concepts of time, speed, and distance, and their correlation with each other. So we had studied the formula of speed is equal to distance upon time, and also its relation with each other, like direct proportionality, inverse proportionality. Inverse proportionality will be when distance is constant, then speed will be inversely proportional to time. Direct proportionality when distance is constant, then speed time product will be constant, right? Okay, so this is the direct and inverse proportionality relation we have studied. Also time saving shortcut techniques to solve different distance time problems. We had studied different strategies to solve the questions within fractions of seconds. Okay, using this shortcut techniques you can also solve different type of board streams, train problems, etc. Okay, also we have studied relative speed, average speed concept to crack different questions related to trains, board streams. Okay, students. So this was all about time, speed, and distance. If you have any doubt, if any difficulty in any part of the chapter, you can comment in the below section. Till then, stay tuned and thank you.